Here we have two questions, question 12 and 13. Question 12. Determine the inverse of the relation f of x equals to 3 times within brackets half x minus 1 square minus 2. How can you restrict domain range of f of x so that its inverse is a function? And question 13 is, consider a relation between x and y that consists of all points xy such that the distance from xy to the origin is 10. And then you have to figure out, is the point minus 8, 6 in the relation? Is the relation a function or not, right? You have to explain that part. So copy these questions, answer them yourself, and then look into the video. It's just a reminder for you, okay? Now, here's the solution. So to find the inverse of a function, what are the steps involved? First, you could write the equation in y equals to x forms, right? And then, so first step is always write the equation as y equals to 3 times, let me write half x minus 1 square minus 2, right? Second step is interchange, swap x and y, right? So we get x equals to 3 times half y minus 1 square minus 2. And then solve for y. So we get x plus 2 equals to 3 times half y minus 1 square, right? So we'll divide by 3, we get x plus 2 over 3 equals to, within bracket, half y minus 1 square. And then we will square root it, right? So we'll have, whenever you square root, you have to write plus and minus, right? And we get here x plus 2 over 3 within the square root, and we get here half y minus 1, correct? And to get the value of y, half, we'll first bring 1 this side, we say 1 plus minus square root of x plus 2 over 3, right, equals to half y, and then we can multiply by 2 and then get y equals 2. So when I multiply by 2, let me multiply by both of them, we get 2 plus and minus 2 times square root of x plus 2 over 3. Is that okay? And then we can write this in inverse form back. That is most important, which I have seen many times students miss. So we write f inverse of x is equals to, so we normally write this part first. Okay, so let's write this like plus minus 2 square root of x minus 2 over 3, right, plus 2. So that's our inverse function. So we've done that part. Second part is how to restrict domain and range. Is the inverse a function? Inverse is not a function. Why? Because we got plus minus 2 here, right? So normally, strictly speaking, if I find that this is not a function, I should only write inverse, right? F inverse. And I should not write within this, indicating that's just a relation, inverse relation, okay? Now, let's try to see how to restrict our domain range. If I have to sketch this function, where is the vertex? So what value will give us 0 here? See, half x minus 1, right? So if I equate half x minus 1 to 0, let me do that part. Half x minus 1 to 0, what do I get? I get 1 goes there, right? So we get half x equals to 1 and x equals to 2. So we have a vertex at 2, okay? Not at 1 or something like that, correct? If I put x as 2, then 2 divided by 2 is 1 and 1 minus 1 is 0. So the vertex is at 2, right? So this is kind of important for you to understand. So we have vertex at 2. Okay, and the value is minus 2. So we have a vertex, let me see, vertex V is at 2 and the value is minus 2, correct? That is my vertex. And the graph opens upwards from 2, right? So basically the graph is kind of like this. Let me use red pen. Just fill. And this point for us is 2 minus 2. Now since the graph fails horizontal line test, for example, if I draw a horizontal line, it crosses at two places. Therefore, the inverse of this function is not a function, as you can see here, right? We got plus and minus. So for every value of x, except for the vertex, for every value of x, you will get two values for y, and therefore it is not a function, right? You don't have a unique value associated with the x value for the inverse function. So to restrict it, what we can do is, we can only consider one part of the graph, right? So if I restrict the domain to, let's say, x greater than or equal to 2, in that case, I am only considering this part of my graph. Do you see that? Not this part. Then horizontal line is fine because the other part is not there, right? So if I use greater than 2, then I have landed with plus sign here. If I use less than 2, I will land with minus sign here, right? So that is the answer to restricting domain or range, right? So we'll restrict domain to x greater than 2 to ensure that the inverse is a function, okay? And if we do this kind of restriction, then the equation of inverse will be f inverse x is equals to plus 2 square root of x minus 2 divided by 3 plus 2. Do you understand? If I restricted x minus 2 less than 2, in that case we'll use minus sign here. Perfect. So I hope you understand that part. Let's go to question 13. Consider a relation between x and y that consists of points xy such that the distance from xy to the origin is 10. So what is the kind of function we are talking about? Do you know that? Well, if you remember circles, then you can answer this question. So we are basically talking about a point which is same distance away from origin. So that will actually make a circle, right? Correct? And what is the distance from origin? The distance from origin is 10. So we are saying that this distance is 10 here. And so here it will be minus 10. Is it okay? So these are your set of points. These are my xy's. Do you see that? And they are all 10 units away. So from here they are all 10 units away. Do you see that? They are all 10 units away. That's what we mean. Consider a relation between x and y that consists of all points x and y, such that the distance from xy to origin, this is the origin, is 10, right? So that is our function. Do you remember the equation for the circle? Well, you can always derive it, right? If I draw a perpendicular, x square plus y square is 10 squared. Do you see that? That's so simple. You don't really have to remember the equation, right? So we'll write here our equation. Let me just put it in here. We'll say x square plus y square equals to 10 square, which is 100. Okay? Don't write 10. 10 square. So that 10 is also a mistake which at times you will see in test papers, right? So that's the equation of circle. And how we got it? Just drop in a perpendicular, right? You know x is this and that is y. And this is your 10. So x square plus y square is 10 square, which is 100, correct? Now, is the point minus 8, 6 in the relation? Plug in minus 8 here. So minus 8 square is 64, correct? So we'll do it here. So if I plug in minus 8 here, minus 8 square is 64. And if I plug in y as 6, 6 square is 36. What do I get? 64 plus 36 is 100. So yes, this is in our relation, right? Is the relation a function? Well, it is not, because if you draw a vertical line, it intersects at 2 points. If you draw even a single vertical line which intersects at 2 points, that's not a function. So it is not a function, it is just a relation. Okay, so I think we have answered all these questions and you have understood how to solve this kind of problem. Okay, thank you.